today we're doing two sum in C# and Java. So first we're going to start with the brute force implementation, and basically I'm gonna read the question first, and then I'm going to explain how we're going to do the brute force implementation. So the question goes, given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So we're given an array of integers. Let me just draw that. Okay, we're given an array of integers. So this could be 2, 7, 11, and 15. So this could be nums. So we're given an array of integers, nums, and an integer target. So the target could be, we're just gonna call this t. The target could be something like 9, and we are supposed to return the indices. So I'm going to put the indices here. So this is index 0, 1, 2, and 3. We're supposed to return the indices of the two numbers such that they add up to the target. So in our case, that would be 2 and 7. So 2 plus 7 is equal to 9. So we would have to return 0 and 1. Okay, so how do we go about doing that? So in the first solution we're going to explore, we're going to use a nested for loop to basically loop over the array and then loop over the array again. So what that's going to look like is we would have our first for loop. So this would be for I, and then inside of for I we would have for j. Ooh, it's a bad j. How do I undo that? Okay, yeah, you would have for j. Okay, for j, and this loop would compare each element to the ith element. So for example, we would start with 2 at I, and j would be I plus 1. So whatever I is, whatever the index of I is, just add 1 to it. So if it's 0, we're going to add 1, and j is going to start at 1. So j is going to start as 7, and it's basically going to add 7 to 2, and then if we do get our target, it's going to return I and j because those are the indices of um, the numbers that add up to the target. So imagine this was an 8, and then this was like a 7, and this was maybe a 1. So what would happen is we would start at 2, so I would start at 0, so at 2, and then j would be 1, so j would be 8, and this adds up to 10. And 10 is not the target, so I would increment, and now I would be 7, because 7 is at index 2 now. And then this is index 3, and this is index 4, because 7 is now at index 2. And then 7 plus 2 is actually 9, so that would be correct. And we would return 0 and 0 and where's, oh man, this is so confusing. 0 and 2, yeah, we would return 0 and 2. I have some very bad handwriting. Okay, so let's go over to the code editor and do this in C# and Java. I think it should make a lot more sense once you see the code. But it's basically this, 2 for loops and the sum, compare the sum, and then return the indices. Okay. So I'm going to start in C#, and what I'm going to do is create the first for loop. So for int I is equal to 0, while I is less than nums dot length I plus plus. And then we're going to have our second for loop. So for int j is equal to I plus 1. And remember, this is because we want to start at the element next to I. So if I is 7, we wouldn't want to start at 2 because we have probably already added 2 to all these numbers. So we would know in that case that 2 plus 7 is not the target. So we want to add 7 to everything we haven't added it to yet. So that's why we're saying I plus 1. So then I'm going to say j less than nums dot length. Also, one kind of main difference between C# and Java is the method names. So in Java, this would be a small letter. And I think in the Java implementation, that's probably the one difference that we're going to have in this specific answer. Okay, so now we have our two for loops, and we're going to find the sum of the elements at those indices. So, ooh, it's int sum is equal to nums at I. Let's start with j. Nums at j plus nums at I. And we're going to say if the sum is equal to target, we want to return the new int. So we want to return an array with I and j. So so if the sum is equal to the target, then this means that we found our two indices. And then if we don't find our indices that add up to the target, it means that they probably don't exist. And in which case we're gonna have to return an empty array. Yeah, this should be correct. Let's test it out. Okay, nice. It says accepted and all the test cases pass. So we're going to do this in Java, but literally it's just like the only different thing is the method names. In Java, you start with a lowercase, and then in C# it's like an uppercase. But it does get a bit different in our next implementation. Okay, I'm just going to change this. So it's length and length, and that's pretty much it. Everything else is the same, and this should run. Nice. This works too. Okay, so this solution has a runtime complexity of O of n because you have two loops. Like you have a nested for loop, and if the data set was huge, then this would take forever to execute. So now we're going to go over the efficient solution, which involves using hash maps. So a hash map is a data structure that pairs keys to values. So what that means is, that, wait, oh, this only zooms in. How do I scroll? Okay, yeah, what that means is that you basically have something like this, and it stores the keys and the values. So in our case, we're going to use the hash map. Well, actually, let me try to explain it like this. So let's look at our array again. So we have 2, 7, 11, and it was 15, I believe. And our target is 9. So we know that 2 and 7 give us 9, but in this case, 2 and 7 are also the complements of each other. So if I take 9 and I subtract 2, I get 7. And if I take 9 and I subtract 7, I get 2. So this means that if I subtract the ith element from the target, I will get a complement. And basically um, I have my solution if the complement exists in the array. So what we can do is take these numbers and put them in a hash map and basically have these elements as keys. So I would have 2, 7, 11, and 15 as keys and their indices as their values. So this is because we want to return these indices, and we would essentially be calculating the complements and then checking if they exist. So we're going to be checking if the key, so the complement as a key, exists so that we can return its value, its index. So yeah, that's basically how we're going to use hash maps to solve two sum. Uh, I think it's going to make much more sense once we do it in code. So I'm going to go back to LeetCode and we're going to solve this problem using a hash map. And the reason we're using a hash map is because it has an O of 1 time complexity for its operations. So it's pretty quick. It's better than creating another array or something like that. Um, okay, so let's do the solution. So, okay, nice. I'm gonna switch back to C sharp because I believe the C sharp answer is a bit longer. So I'm gonna start with that. So I'm gonna leave this in because we do want to return an empty array in the case that we don't find two indices of the elements that add up to the target. So to start, I'm going to need to create our hash map. So in C sharp, a hash map is called a dictionary, and so then now you have to pass in the types of the key and the value. So it's int. So our key is going to be an integer and our value is going to be an integer because we're storing the values and their indices. So they're both integers. I'm just going to call this hashmap complements, and this is a new dictionary. And then I need to pass in the types again. So this is also something that's unique to C Sharp. In Java, we wouldn't have to like redo the typecasting. It'd just be like dictionary with two curly braces and then these brackets. Okay, so now that we have our dictionary, we're going to loop over the numbers and then calculate the complements. So it's for int I equal to 0, I less than nums dot length I plus plus, and then we are going to calculate the complement. So to calculate the complement, we're going to say int complement, and notice that this is complement and not complements, is equal to the target minus nums at I. Okay, so this will give us the complement. So next we're going to check if the hash map complements contains key. So remember how we're using the complement as the keys and not the values. So this is why, so we can check if they exist directly. So if complements dot contains key complement, we're going to return the array of the indices. Return new int I and complements complement. So I'm getting the value of the complement. So which is its index. Okay. So if it does not contain the key, we're going to add the current number as a complement. So we're going to say complement dot add, and then we're going to take the value as the key and the index as the value. Okay, so we're adding this because at the beginning our complements hash map is going to be empty. So let's just walk through with this array. So what's going to happen is we're going to start with an empty dictionary, and then we're going to loop through this array. And we're going to start at 2, so index 0, and we're going to calculate the complement. So 9 minus 2 is 7. So we're going to check if this hash map contains the key 7, and if it does, we're going to return 0 and whatever value 7 has. And if it does not, we're going to add 2 as a key and its index. This is because when we come to the next element, so at I plus plus, so that's going to be 1, so the index of 1, we're going to calculate the complement, and the complement is going to be 9 minus 7, so that's 2. Now when this runs and checks for contains key and it's looking for 2, it's going to find 2 because we added 2 to the hash map, and that's going to return I, which is 1, and the value of um, the key 2. So that's going to be, what is this, 0. And yeah, that's the solution. Let's run it. Nice. So this has a runtime complexity of O of n because you only have one for loop. And remember, our hash map has a time complexity of O of 1 for its operations. So it's basically n plus 1, which simplifies to just n. So it has a runtime complexity of O of n. So now I'm going to show you how to do this in Java. Okay, let's switch to Java. Okay, so there's going to be a number of differences. So the first one is that in Java, we call hash maps hash maps. So it's a hash map. And instead of using int, we're going to use wrapper classes, integer. So these are wrapper classes on the primitive types, int. So I think they just give the traditional int a bit more methods that I guess help it work with data structures like the hash map. So we're not going to be using int, we're going to be using integer. And then we're going to give it a name, complement equal to new hash map. And we don't need to pass the data types again. We can just put these bracket these, and then now we're going to loop through the array. So for int I equal to 0, while I is less than nums, and length with a lowercase l, I plus plus. So from here we're going to do the same thing and calculate the complement. Nums I. And then we're going to check if the hash map contains the key. So remember, lowercase c contains key. And the key we're looking for is the complement. And if it does, we're going to return the array with the indices, complements. And in Java, it's a method dot get, and we're getting complement. Okay, so if it does not, we're going to add the current element into the hash map. So we're going to go complements dot put. It's not add, it's put and get. So when you get something from a hash map, you don't use square brackets, you use get and then pass its key. And then when you're, I guess, putting something into the hash map, you use put instead of add in C#. So it's put, and we are putting nums at I and its index. And this should run. Nice. Yeah, so that's how you do two sum in C# and Java. I hope you guys found that helpful. See you in the next video.